Assessment of land degradation and desertification approaches. Land degradation, as has been pointed out by the UNCCD, is a global development and environment issue that affects mostly developing countries regarding the economic impact and food security. The assessment and monitoring frameworks developed to provide information about land degradation have been very valuable. However, there are some opportunities to improve and test methodologies according to regional and country needs. Land degradation and desertification are concepts that are strongly related. Land degradation can be defined as the loss or reduction of the biological production of farmlands, grasslands, forests, and wooded areas and is the result of intense land use or process, or a combination of the process, including those coming from human actions. It is the outcome of the mismatch between land quality and the intensity of activity part of the actual land use. According to the UNCCD, land degradation is a complex set of processes of the impoverishment of terrestrial ecosystem, either natural or human-induced, that causes the land to be no longer able to sustain its economic functions or the original ecological functions correctly. The consequences of land degradation are land productivity reduction, socioeconomic problems, including uncertainty in food security, migration, and damage to ecosystems. Desertification, on the other hand, is defined as land degradation occurring in arid semi-arid and dry subhumid areas caused by a combination of climatic factors and human activities. Therefore, only land degradation occurring in drylands is considered as part of a desertification process. As many climatic scenarios have to point out, many areas across the world are vulnerable to climate change because it is going to accelerate the degradation process. This project was one of the first attempts to assess the state of degradation of soil from a global perspective. The world map produced by Gilad showed the status of human-induced soil degradation and was based mainly on expert judgment and reported degrees of land degradation that also included the notion of resilience, which was deemed essential for land management decisions. Although the Gilad project had some criticism about the methods used, it was the only global assessment available to scientists, decision makers, and land managers to date. The LADA approach was developed based on the assumption that human activities on the land are the main drivers causing land degradation. Therefore, defining and mapping of different land use systems are very crucial activities for underpinning the assessment and its implementation. The entire LADA approach gives consideration to the relationships between the causes and effects that lead to degradation. The LADA project operates by using a variety of technologies, from satellite images to digital databases, to soil and vegetation sampling, and the examination of the linkages between both biophysical and socioeconomic issues. Global assessment efforts list net primary productivity, NPP, rainfall use efficiency, RUE, aridity index, AI, rainfall variability, RV, and erosion risk, ER, as the leading indicators of land degradation. The Global Land Degradation Assessment, GLADA, was the global component of LADA. GLADA aims at providing a baseline for the assessment of global trends in land degradation using a range of scale-appropriate indicators, many of which are collected through satellite sensors and processing satellite data and existing global databases. Methods for monitoring current state and changes of landscapes use the advantages and potential of satellite-borne or airborne remote sensing imagery. Most work has focused on identifying the change and detection of decreases in land cover rather than identifying the inverse process. Considerable amount of studies explore the capabilities of remote sensing on different monitoring applications and different remote sensing approaches and data. Remote sensing applications can be summarized mainly in 4 categories that include cover classification, estimation of structures, change detection, and modeling. Remote sensing has the potential to be decidedly instrumental in the assessment of degradation processes at a much lower cost than any other method. Assessment, i.e. measurement, and monitoring through remote sensing offer a series of advantages such as consistency of data, fairly near real-time reporting, and a source for having spatially explicit data. Although there are several approaches to describe land cover changes using remote sensing technology, forest inventory and limited sampling of degradation on the ground are fundamental to its quantification. The methods used are unique to each location and strongly dependent on how its components are clearly identified and responsive to accurate measurement, and how country requirements apply to these methods. Remote sensing is a suitable tool for the estimation of biomass for large areas, usually at regional or national scales, where field data are scarce. There is an abundance of literature that describes the virtues and capabilities of remote sensing-based methods for forest monitoring assessments. The continuing advances in remote sensing science and technology and the enormous amount of data these platforms and sensors produce daily provide a promising foundation to underpin any degradation monitoring program. The possibility of integration of optical and multispectral remote sensing data to active sensors such as LIDAR, light detection and ranging, and radar, radio detection and ranging, combined with ground data, has gained a significant relevance and a high potential for contributing to the design of degradation assessment and monitoring methodologies. Direct detection of degradation processes, for example in forest landscapes, relates area changes to, and focuses on, forest canopy damage. These changes in forest attributes occurring during a period of time can be detected using information from natural forest resources inventories, FRI, and some from remote sensing. Medium spatial resolution satellite remote sensing data such as Landsat Thematic Mapper, TM, and SPOT have proven capable of obtaining regional scale forest variables. Indirect approaches focus on the spatial distribution and the effects that the evolution of human infrastructure has had on the degradation of nearby areas. Often, these indirect factors are used as proxies for newly degraded areas.